And now it's my incredible honor to introduce Carole King and as the host of our next session. You know, Carole is a singer-songwriter. She is an icon. She has really told the stories throughout the ages of our lives and through her music. And she's dedicated 3 decades now to working to protect our planet and the creatures with whom we share it. She's worked in the Northern Rockies to create a whole ecosystem protected. She's worked on behalf of our forests and primarily with the group called Alliance for the Wild Rockies. And today she's bringing to the stage with her an attorney. So Katie Bilodeau is staff attorney at Friends of the Clearwater here in our Idaho region. And then we have Chad Hanson, who's director and principal ecologist at the John Muir Project. So they're going to have a conversation about leaning into nature in this time of climate crisis. So please join me in welcoming Carole and her colleagues to the stage.
Well, hello, everybody. Thank you for coming to hear us speak. I am really the facilitator of this discussion, so with that, I'm going to turn this over to Katie Bilodeau.
Thank you. Let's see. Okay, well, these are some satellite pictures at the same scale, and I wanted to orient you to them. The brown polygons that you see in both pictures are recently cleared areas. The light green is shorter vegetation, like meadows and croplands, or vegetative recovery from the brown areas. Usually you can tell what's the work of human hands when they're odd-shaped polygons with sharp edges, or straight edges and sharp corners. The dark green you see in both of these pictures, they're forests that either haven't ever been logged or haven't been logged in a very long time. On the left, we have the Brazilian Amazon rainforest, and as is true within the rainforest for the Democratic Republic of the Congo and the Philippines, when trees are cut there, we call that logging. On the right-hand side, there's another rainforest. It's the Clearwater National Forest in Idaho, and I brought my road atlas up here to kind of show you where we're talking about. So we're here right now, and the Clearwater is up here in this part of Idaho. The Clearwater National Forest is the southernmost part of one of the largest inland temperate rainforests in the world. And when trees get cut here or anywhere in our national forests in the United States, our government calls it silvicultural treatments or forest restoration or making forests resilient. And we need to take ownership back from this. In this age of climate crisis, we must re-examine the sanitizing language our government uses when they're communicating to us about how it manages our public lands. And we need to protect our own forests at home as we encourage other countries to protect theirs. Oh, sorry, I'm gonna back up for a second. So if you look in the outline part of the box on the right-hand side, let's see here. Okay, that box is up there. We've zoomed out a little bit. Google Time-Lapse is a useful tool for landscape change over time. You see from the bottom here, this kind of cut that is like a road from the southwest to the northeast. That's the Lochsa Wild and Scenic River in the general area of the state I just showed you. And I want you to remember these general areas because I'm going to take away the borders in a second, and we're going to flip through what this landscape looks like over time. So on the very right-hand side, we have the Selway Bitterroot Wilderness. On the general right-hand side, we have inventoried roadless areas, which I'll also refer to as roadless areas. On the general left, we have national forests that aren't designated as roadless areas or wilderness areas. And on the very, very far left, we have the public land that is part of the state of Idaho, as well as private land, which is mostly owned by timber companies. So remember these general areas, because I'm going to take away these borders now. Okay. In 1986, there was a lot of logging in the general forest because this area isn't steep country, and so the easy-to-access roads or easy-to-access timber has been cut, and the easy-to-access roads have been built. In 1986, those new brown spots you see are the newly logged areas, and as I flip through, you'll start to notice this is happening where the dark brown areas are, or the dark green areas are, excuse me, because the light green is recovering forest. And so I'd probably ask you guys to look maybe about here or the dark green areas as we kind of flip through these years. So this is 1991, and as you watch these areas turn brown, watch the light green areas as well because they slowly become darker green. And what you'll notice is the rate that we're acquiring more of these brown polygons is outstripping the time. It's faster than it takes the light green to turn to dark green. And you'll also notice that border that demarcates the edge of the forest as it goes to state and private land is becoming more apparent just from the landscape. So, and then I'd ask you between 2015 and 2020, if you remember, this is a roadless area here. So look at this corner when I go from 2015 to 2020. And you see a little bit of that is gone. So roadless areas are not, they're still vulnerable to logging. Since 2008, under Idaho's roadless rule, the Forest Service, under the Idaho roadless rule, has authorized 177,000 acres of logging. And I don't have time to get into why. Friends of the Clearwater has a report about this on our website, and I'd be more than happy to answer questions later. But wilderness is a standard that we should be aiming for. It is the strongest substantive US law that protects habitat. And now that we've seen kind of this landscape change, I'm going to turn this over to Carole to show us what it looks like from a ground level.
Do you have can you click, or is it the Feller-Buncher video?
I don't know if I can.
If you want to go ahead and start it, I can talk over it. I did not know. I knew that the logging was becoming mechanized, generally thought about it. Okay, right. And I knew people that had lost their jobs because one operator in one of these machines can do what you're seeing. So, grab a tree, saw through it, lay it down. It's already been stripped. Some of them have machines that strip the leaves. And they're going for another one. Just grab it, saw through it, and put it in a pile. So it's not a tree anymore. It's a log. This is what's happening. Imagine how quickly they can destroy an entire forest or an entire, what we know as clear cuts. And clear cuts are what is happening more than anything. The cure for this, what we can do is protect these unprotected roadless areas that Katie referred to, IRAs, you might hear them talking about, but inventoried roadless areas are the only lands that are eligible for protection as wilderness. Once they do this, those lands are no longer eligible for protection. We have the Northern Rockies Ecosystem Protection Act, which would protect a vast area that includes what Katie showed you on her map and her slides. And I'll turn it back over to you.
Thank you, Carole. So before we launch into this, Friends of the Clearwater and the John Muir Project are grassroots organizations that are primarily funded by individual donations. And this allows us to maintain our strong land ethic and follow the science. And if you have any more interest in this, I'd encourage you to visit our website at friendsoftheclearwater.org and thejohnmuirproject.org. So with that, so the Forest Service might not call these logging projects anymore. They might say they're fuel reduction projects, they're salvage sales, they're vegetation management projects, but substantively, it's relatively unchanged from a logging project. Logging by any other name, it still degrades. Names don't really matter because the functional equivalent is there. These projects have all taken large trees, destroyed wildlife habitat, and has emitted carbon into the atmosphere. Friends of the Clearwater right now is in court trying to stop a 3,000-acre titled restoration project that would leave very large clear cuts and log some old growth. And the Forest Service and its affiliates will talk about tree planting, but you should know that that's only necessary because they've logged these areas first. Like when you clear cut under the National Forest Management Act, there is a requirement to replant those trees within 3 to 5 years. So this is what silvicultural or mechanical treatments look like on the ground. And to the left is the feller buncher that you just saw a video of. To the right is a swing machine, which is a machine that picks up logs and kind of puts it into an area where it then can be loaded on trucks. One of the measurements in the logging industry is called a board foot. It's a volume measurement of timber. And it's the equivalent volume of 12 inches by 12 inches by 1 inch. And trucks like these can haul anywhere from 3,000 to 6,000 board feet of timber. And to give you an idea of the size that is coming off our national forests, in 2020, on the Nez Perce and Clearwater National Forest, the Forest Service sold 84 million board feet of timber. That is about 14,000 to 28,000 truckloads of trees they'll be hauling away. What you'll also notice from these trees that are stacked on the truck is that they're missing branches. So this is the other part of logging, is they usually strip the branches on site, and this is what the Forest Service will call logging residue, and they put them in what is called slash piles, which will end up getting burned. So various carbon accounting studies show that logging is the biggest carbon emitter on our national forests. Logging emits 3 times more carbon than wildfire, and then the wildfire the Forest Service claims that logging will fix. And you'll see that only a fraction of the carbon in a living tree will end up being stored in a final timber project or a final wood product if it gets logged. What you see is the logging residue, which you saw on the last slide, gets stripped away. That's some carbon emissions. The mills have to cut trees further down, which is more carbon emissions, and there's transportation as well. For living trees, logging stops the carbon sequestration process, which is where the tree pulls the CO2 out of the air for us. And the larger the tree, the larger the loss of that service. Okay, well, I want to talk more about the cold, clear streams that nature can give us and how logging degrades that. And the impacts boil down to sediment from the roads that are built to access trees to cut. Many fish in Idaho start their lives in forest streams. And in a warming climate, it's very important for fish like salmon and steelhead to have cold, clear streams as late into the summer as possible. With clear cuts, the snow disappears earlier. Either it goes straight into the atmosphere, or it will be an earlier melt and an earlier runoff into the stream. But also important is the gravelly rocks and the gaps between those rocks. Salmon and steelhead lay their eggs in the gravelly places, and fry, which are salmon and steelhead babies, hide from predators in the gaps between the rocks. And sedimentation impacts all of this. This is a cross-section of a stream, and this is why chronic sedimentation is bad. When it's floating in the water, when the fine dirt is floating in the water, it increases stream temperatures. But the fine sediment can also it can bury those loose gravelly rocks, and it's called cobble embeddedness. It's where the fine dirt comes in and buries the cobble. For fish eggs that are already laid, it buries them, it seals them into a little tomb. And for fry, the baby salmon and steelhead, it eliminates the safe space that they can hide from predators while they're waiting to migrate to the sea. The takeaway from this slide, this is a slide about cobble embeddedness as it pertains to steelhead. And the higher the cobble embeddedness, the lower the habitat quality for fish. Now, most of the sediment comes from roads. In 2022, the Forest Service has already built the easy-to-build roads to access the easy-to-access timber. What you see here on the right is a temporary road that's built into an inventoried roadless area. Most of the trees that you see in that picture on the right have since been logged. And notice that the cut is pretty substantial into the natural hillside. The natural hillside starts at the green, and that's about, I think it's about 8 to 12 feet off of what the road is, which is quite the disturbance. All right, how does sediment get into the streams? Well, on the left, next to the creek, you'll see the dust kicked up into the air by a passenger truck that's driving right next to a stream. And on the right, rain transports sediment, which runs down ditches, goes into culverts, and makes their way into streams. The Forest Service can't upkeep their current road system, and clear cutting and soil saturation are known factors for landslides. If the road sits above a stream, that sediment is going straight into the stream. Global warming suggests that we might see more landslides with more precipitation as rain as opposed to snow, which means the soil is going to absorb more of the precipitation and become more unstable. Let's see. So we know that logging means building roads, that roads create sediment, and that sediment runs into streams and degrades fish habitat. And I wanted to show you a map that is an aggregate of the issue we're seeing. So in the Nez Perce National Forest, which is the general area I showed you at the beginning, it's about here in Idaho. You can see Highway 95 on the left side. Highway 95 is the Grangeville, Whitebird, Riggins, and then the Kuski up top is the beginning of Highway 12. So in 2000, the Forest Service created this map. And inside the boundaries of the National Forest are the red and green lines that are all of the roads on the National Forest System. And the red lines in particular are the roads that the Forest Service identified in 2000 as unnecessary roads. And I believe most of these roads are still in the inventory. Well, occasionally the Forest Service decommissions roads. This decommissioning is often rolled into logging projects that build new roads like the one you saw into the inventoried roadless area, or reconstructs existing roads. And I want to leave you with a final thought before turning this back to Carole. Nothing is wrong with a dead tree in a forest. It's going to eventually fall to the ground. It's still going to store a lot of that carbon. It's going to put nutrients back into the soil. And as it slowly decays, the structure is going to be used as wildlife habitat for nesting and denning species. The Forest Service often proposes restoration or silvicultural treatment, which is logging, for reasons rooted in fire, such as fuel reduction or removing diseased trees that the Forest Service argues might lead to a high-intensity fire. But I'm going to turn that back to Carole because they can talk more about this.
Thank you, Katie. I'm probably going to have a little more to say that I would like to say, but just to tie this together, the title of this presentation is Fire and Rain. I had to do it. But it really is important because Katie told you all about the roads and the impact on salmon. Dr. Hanson is a fire ecologist, well, he's an ecologist, and he has taught me so much so that when I make my case about the Northern Rockies Ecosystem Protection Act in Congress, I can now bring so much of what he has to say to make the case. And with that, I will turn it over to Dr. Hanson.
Thank you. Thank you very much. So I'm going to talk a little bit about some of the myths and misconceptions about wildland fire in our forests. And the key thing I'm going to kind of leave you with today is there is a narrative out there that's being presented by the logging industry, including the U.S. Forest Service. And a lot of folks in this room, I'm sure, know this, but not everyone does, that the number one thing the U.S. Forest Service does in terms of land management is sell public trees to private logging companies and keep the revenue. The US Forest Service is literally in the commercial logging business like a giant logging corporation, except it's funded and subsidized by taxpayers. And a lot of members of the public, a lot of environmental organizations, a lot of scientists, including myself, believe we need to get the US Forest Service out of the commercial logging business. Because one of the key things that's happening is that because they're fundamentally incentivized financially, they need a narrative to keep the logging program going. And so what they're telling the public is, we need to do all this forest management, all this fuel reduction, forest health work, restoration, which all means logging, these are just euphemisms, supposedly to stop catastrophic wildfires from destroying our forests. They spin this image of fires destroying the forests, incinerating the trees, sterilizing the soil where nothing will grow, and they ask the public to accept the impacts of logging as the lesser of two evils. So I'm just going to address the reality of what's happening in the forest in terms of logging and fire. Now, if you want a lot more information, I came out with a book last year called Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate, and there's a lot more information in there. I wrote it in a narrative format that was written for non-scientists, for general public. But I'll just kind of synopsize some of the key things. When a tree is cut in the forest and for logging purposes, and it's removed, the key thing is only a small percentage of the carbon in that tree ends up in a wood product somewhere, in a home or an apartment building or some other structure. Most of the carbon in that tree ends up in the atmosphere almost immediately, because the branches and the treetops and the bark and all the mill residue is incinerated, is burned for energy at biomass plants or at the lumber mill. And we call this clear cuts for kilowatts. And a lot of people don't realize logging in the US emits nowadays as much carbon into the atmosphere every year as burning coal in the US. They're comparable. So logging is a huge source of carbon emissions. Now, on the opposite side of the spectrum is wildfire. Turns out, yes, of course, wildfire emits carbon into the atmosphere, but far less than we thought in the past, far less than the Forest Service would like us to think. We just published a study on this after 4.5 years in the field in 2 really large fires. Turns out that only 1%, a little over 1% of the tree carbon is consumed, even in a really large, intense forest fire. Only a little over 1%. Now, trees they survive fire mostly. Some trees are killed in fire, but the carbon stays there in the forest. Now, when these so-called thinning operations happen, a lot of people don't realize thinning is commercial logging. It's very intensive commercial logging. In fact, the typical so-called thinning project on national forests kills and removes over 70% of the trees in a given stand, including many mature and old-growth trees. And this is what it looks like. You basically have these widely spaced mature trees and almost nothing else. Most of the forest, a lot of the biomass has been removed from the forest. And that has huge climate change impacts because, of course, logging, including commercial thinning, emits 3 times more carbon into the atmosphere per acre compared to wildfire alone. And the interesting thing is the Forest Service and the logging industry tell the public, and they tell Congress, that these thinning projects, so-called, are being done supposedly to stop fires, what they call catastrophic wildfires, pejoratively. And the reality is, really what these projects are doing is putting a lot of carbon into the atmosphere. They're not stopping fires. And in fact, in many cases, the fires are burning faster and more intensely through the areas where the forests were logged under the guise of thinning. This is an example of that. This is the Creek Fire that happened in 2020 in the southern Sierra Nevada. And there are many, many areas like this all over the West where thinning was conducted, so-called, and the fires burned through, didn't stop the fire, and they often burn even more intensely. And this is another example here. You see the forest was very open because most of the trees had been removed. But that didn't stop the fire, and it certainly didn't make it burn less intensely. The fire burned and killed all the trees in these areas. And so thinning is not a fire management solution. This is just a narrative that's being presented to the public to keep an outdated and ill-advised commercial logging program going on our national forests. Now, one of the other key things is when fires occur, we're told the forests have to be reforested. And there's this massive unmet need of reforestation. When you hear this, even from well-meaning people who don't know better necessarily, understand that you are being given information that is not grounded in science. It's not accurate. Forests naturally regenerate after fires, just as they've been doing for millions of years, including in areas where all the trees were killed, including in large patches. This is an area here. This is me and Dr. James Hanson, climate scientist, in the Rim fire last year in a large high-intensity fire patch, one of the many that the Forest Service said would never naturally regenerate or would take a couple hundred years to naturally regenerate unless they restored it and reforested it, by which they meant clear-cut it and plant tree plantations. And you can see that the forest is naturally regenerating. The trees, this was last year, 8 years post-fire, they were already over the tops of our heads. Right next door, just a couple hundred meters away, this was the same high-intensity fire patch in the same fire, in the same stand, but the Forest Service did what they called 4 years to 5 years earlier, restoration and reforestation and fuel reduction. In reality, what this was clear cutting, planting of young nursery-grown trees, almost all of which died because there was so much soil damage from the logging equipment. And then what you've got is just a stump field and some invasive grasses coming in, where the invasive seeds were brought in by the logging equipment. And this is what the Forest Service is telling the public, and some well-meaning but misinformed NGOs are telling the public that we need reforestation. Don't believe it, this is what it really means. Here's another example. This is an area that one of the largest high-intensity fire patches in the entire Rim fire. This is on public lands. This is the very interior of that at 8 years post-fire. This is all natural regeneration. Just for perspective, these trees are about twice my height already, just at 8 years post-fire. And these are over 1,000 feet from the nearest surviving tree in any direction. Right next door, 5 years earlier, the Forest Service did what they called restoration, fuel reduction, and reforestation. And this is what it looks like today, still years later. Most of the planted trees died. Now, of course, some of them don't die. In some areas, more trees that they plant survive. In other areas, almost all of them die. So there's some variability. But the point is, forests don't need our intervention after fires. They are regenerating on their own, just as they have been for millions and millions of years. Mixed intensity fires go back 350 million years in evolutionary history in the forests of this planet. Forests do not need our help. And this is clear cutting after fire for biomass plants. Again, we call this clear cuts for kilowatts. This is on public land that's being subsidized by taxpayer dollars. So that's the bad news, but the good news is we can stop it. We can put pressure on policymakers and on our members of Congress, our US senators, our members of Congress, and ask them, urge them, insist that they get the US Forest Service out of the commercial logging business. Now, one of the other key things, and I know a lot of people are really concerned about giant sequoias and fire, and I understand that. Giant sequoias are incredible, majestic, and endangered tree species. However, it's really important to understand that the main threat to giant sequoias for over a century, for about 130 years, is an extreme and profound lack of reproduction. These big old mature giant sequoias have been slowly dying off and they haven't been reproducing. It turns out giant sequoias need higher intensity fire to effectively reproduce. They don't reproduce effectively with low intensity surface fire. It's almost like unburned. And they reproduce best where you have higher intensity fire. Fire that's intense enough to kill at least some of the mature sequoias. That's their cycle of life. And this is just abundant giant sequoia regeneration in an area that burned 5 years ago. More regeneration coming up through 100% shrub cover. And interestingly, in the low intensity area, in the same giant sequoia grove, almost no giant sequoia reproduction whatsoever. And so it's just important to understand that there's really good news coming out of the science in these areas. Good news, hopeful news. And the last thing I'll mention here, just very briefly, is when fire burns in our forests, it's mostly low and moderate intensity in most fires, but there are patches where the fire burns hotter and kills most or all of the trees. Sometimes in small patches, sometimes in big patches. And it's really key to understand that there's now an abundance of science telling us that that habitat is a unique habitat type we call snag forest habitat. And there are countless plant and animal species that have evolved over millions of years to depend on snag forest habitat, native insects, birds, cavity nesting species, small and large mammals. And it turns out that snag forest habitat is an ecological treasure trove. These areas of dead trees that we thought were destroyed or lost, that we didn't even consider forest years ago. It turns out it's one of the two most ecologically important forest habitat types. It's comparable to old growth forest in terms of native wildlife abundance and diversity. And so it's really important that we protect all of our forests, not just the mature and old forests and the roadless areas, but also the snag forests where fire or drought kills patches of trees. Thank you. And then I'll turn it back to Carole.
Thank you, Chad. So I want to say that on the Northern Rockies Ecosystem Protection Act, send you to a website, allianceforthewildrockies.org. They have the map, what it's about, what it does. I really encourage everybody who's watching to go and look at that. And I wanted to tell you something that you may not know. I was speaking with one of the Youth v. Gov kids that are now adults, and they're still on this lawsuit suing the government for the harm that they've done to their generation. And I pointed out that the Forest Service is under the U.S. Department of Agriculture. Why? Because trees to our government are a crop. Think about that. And last, I just want to thank you for your interest in this. I hope you'll follow up and with friends and neighbors and try to help demystify the fire myth that's that, oh, we have to cut down trees because they're fuel. No, we need to leave them there, and they can take care of themselves. The mature trees actually are mildly harmed, and it's the forest's way of managing itself. And it's so out of control now because of climate and climate-driven weather events. And when you cut down all these trees, you're exacerbating the problem. You're creating a situation in which climate change is speeding up. Oh, is that our map of Northern Rockies?
Sorry.
Yay! Okay, we'll go to the allianceforthewildrockies.org. And I just, I don't know if we have time for any questions. I'm seeing that the clock is winding down. So if I'm being, we have to stick to the clock. And just thank you for coming. And please follow up on these websites, johnmuirproject.org and friendsoftheclearwater.org. Follow up and get more information, get involved, give money, please. But whatever you can do, please stay involved. We need your help to protect our planet. Thank you so much. Thank you.